FastMCP 3 employs a declarative component-based architecture to construct interactive data visualizations, where tools are registered as app endpoints that return structured UI components. The framework's integration with PrefabApp enables seamless rendering of complex charts through composable elements like BarChart and ChartSeries, while maintaining clean separation between data processing and presentation layers. We're about to examine how a quarterly revenue visualization tool is implemented, demonstrating the initialization of a FastMCP instance, the decoration of a tool function with app rendering capabilities, and the assembly of a bar chart component with configured data series and axis mappings. The implementation will showcase the framework's approach to state management and component composition within a single tool endpoint. From Prefab UI, components import column, heading, bar chart, ChartSeries. From Prefab UI, app import PrefabApp. From FastMCP, import FastMCP. MCP equals FastMCP charts. At MCP, toolapp equals true. Def quarterly revenue year, int PrefabApp. Show quarterly revenue as a bar chart. Data equals quarter Q1 revenue 42,000, costs 28,000. Quarter Q2 revenue 51,000, costs 31,000. Quarter Q3 revenue 47,000, costs 29,000. Quarter Q4 revenue 63,000, costs 35,000. With column gap equals 4, CSS class equals P6 as view. Heading, year revenue versus costs. Bar chart. Data equals data. Series equals. Chart series data key equals revenue. Label equals revenue. Chart series data key equals costs. Label equals costs. X-axis equals quarter. Show legend equals true. Return PrefabApp view equals view. This code demonstrates how to create a visual data representation tool using FastMCP and PrefabApp. The quarterly revenue function is registered as a tool with FastMCP, which automatically handles parameter validation and error reporting based on the function's type annotations. The function takes a year parameter and returns a PrefabApp containing a bar chart visualization. The implementation uses Prefab UI components to build the interface. A column layout contains a heading with the year and a bar chart that displays quarterly revenue and costs data. The chart is configured with 2 chart series, one for revenue and one for costs with the quarter as the x-axis. The data is hard-coded in the function, but in a real application, this would typically come from a database or API call. This pattern is useful for creating visual tools that can be accessed through both conversational interfaces via FastMCP and direct UI interactions. The integration between FastMCP and PrefabApp allows the same tool to serve both purposes seamlessly. The approach provides a clean separation between data processing and visualization, making it easy to maintain and extend. However, the hard-coded data means this is more of a template than a production-ready implementation. Let's break it down. From Prefab UI, components import column, heading, bar chart, ChartSeries. Imports UI components from the Prefab UI library. Column for layout organization, heading for text titles, bar chart for data visualization, and chart series for defining data series in charts. From Prefab UI, app import PrefabApp. Imports the PrefabApp class from the Prefab UI app module, providing a base application class for building prefabricated UI components in the FastMCP 3 framework. This class serves as the entry point for creating structured UI applications with predefined components and layouts. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. The imported class will be used to create MCP server instances with customizable identifiers.
MCP equals FastMCP charts.
Creates an instance of FastMCP with the server identifier, charts. The string parameter serves as a label for identification in MCP protocol handshakes, allowing clients to recognize this specific server instance.
At MCP, toolapp equals true.
Decorates the following function as a FastMCP tool with application-level visibility, making it discoverable and callable through the Model Context Protocol interface. The app equals true parameter explicitly marks this tool as part of the application's public API rather than an internal utility.
Def quarterly revenue year, int PrefabApp. Show quarterly revenue as a bar chart.
Defines a function named quarterly revenue that takes an integer parameter, year, and returns a PrefabApp object. The function's docstring indicates it generates a bar chart displaying quarterly revenue data.
Quarter, Q1, revenue, 42,000, costs, 28,000.
Defines a dictionary entry with 3 key value pairs. Quarter mapped to Q1, revenue set to 42,000, and costs assigned 28,000. This represents financial data for the first quarter, showing revenue and cost figures.
Quarter, Q2, revenue, 51,000, costs, 31,000.
Defines a dictionary entry with 3 key value pairs. Quarter set to Q2, revenue set to 51,000, and costs set to 31,000. This appears to be a single data record representing financial metrics for the second quarter.
Quarter, Q3, revenue, 47,000, costs, 29,000.
Defines a dictionary entry with 3 key value pairs. Quarter mapped to Q3, revenue set to 47,000, and costs assigned 29,000. This represents a single quarterly financial record with the specified values.
Quarter, Q4, revenue, 63,000, costs, 35,000.
Defines a dictionary entry with 3 key value pairs. Quarter set to Q4, revenue set to 63,000, and costs set to 35,000. This appears to represent financial data for the fourth quarter, showing revenue and cost figures.
With column gap equals 4, CSS class equals P6 as view.
Creates a column layout container with a 4-unit gap and applies the CSS class P6 for padding, assigning it to the variable view using a context manager. The column class appears to be a UI layout component that organizes content in a vertical column, with the specified gap controlling spacing between elements and the CSS class adding visual padding.
Heading, year revenue versus costs.
Creates a heading with the text 2023 revenue versus costs, assuming year is 2023 using an f-string to dynamically insert the year value. This appears to be formatting a section title for a report or visualization comparing revenue and cost data for the specified year.
Bar chart.
Initiates the creation of a bar chart visualization component. The opening parenthesis indicates this is the start of a bar chart constructor call, though the specific parameters and configuration details would appear in subsequent lines of code. This line alone establishes that a bar chart widget or object is being instantiated, with the actual data binding, styling, and layout parameters to follow in the complete statement.
Data equals data.
Passes the data variable as a keyword argument to a function or method call. assigning the value of the local data variable to the parameter named data in the called function. This is a standard parameter passing operation where the variable name matches the parameter name, creating a clear mapping between the caller's data and the Cally's expected input.
Series equals. Chart series data key equals revenue. Label equals revenue.
Creates a list containing a single chart series object configured to display revenue data with the label revenue. The chart series instance is initialized with data key equals revenue to specify which data field to plot, and label equals revenue to set the display name for the series in the chart.
Chart series data key equals costs. Label equals costs.
Creates a chart series instance configured to display data from the costs key with the label costs. This defines a data series for visualization where the values will be sourced from the costs field in the underlying dataset and will be labeled as costs in the chart legend or axis.
X-axis equals quarter.
Assigns the string value, quarter, to a variable named x-axis. This creates a simple identifier that will be used elsewhere in the code to reference the x-axis labeling or grouping for time-based data visualization.
Show legend equals true.
Sets the show legend parameter to true, enabling the display of a legend in the visualization output.
Return PrefabApp view equals view.
Returns a new PrefabApp instance initialized with the provided view parameter. This creates an application object configured with the specified view component, ready for further setup or execution in the FastMCP 3 framework. This implementation showcases FastMCP 3's declarative component architecture by combining framework registration with PrefabUI's composable visualization elements. The quarterly revenue function serves as both an MCP tool endpoint and a UI component factory, demonstrating the dual-purpose nature of FastMCP tools. By decorating the function with @MCP, toolep equals true, we expose it as an application-level endpoint while maintaining clean separation between data processing and presentation layers. The core pattern emerges in how structured data flows through the system. Raw quarterly figures get transformed into a PrefabApp containing a bar chart with two chart series components. The column, layout, and heading components provide the structural scaffolding, while the chart configuration handles data binding through data key mappings. This compositional approach allows the same tool to serve both conversational interfaces and direct UI interactions without duplication. The hard-coded data serves as a template reminder that while this demonstrates the visualization pipeline, production implementations would typically source data dynamically. The framework's automatic parameter validation and schema generation from type annotations reduces boilerplate, letting developers focus on the visualization logic rather than protocol handling. The result is a maintainable pattern where business logic, data structure, and presentation remain cleanly separated through component composition.
The decorator brands the function, then sits silent as the server hums, waiting for a call that exists only in the code's dreams.